Hi, this is Mrs. Baisden, and today we're going to talk about naming and writing formulas for ionic compounds with single charge metals. So if you remember in the last unit, we talked about how different groups on the periodic table formed different charges when they lost or gained electrons. So we focused mostly on groups 1 and 2, group 13, and then group 15, 16, and 17. We didn't talk about the patterns of charge formation that the transition metals form because we talked about how those can form various charges. So what we're going to talk about first when we learn how to name compounds is how to name compounds that contain these metals that only form one charge. So this is a nice periodic table that kind of shows you which elements we'll be working with. So these are the ones that are the most common. So these are the metals that always have the same charge. So if you look, you notice that these have a pattern similar to what we talked about. So group 1, we see has those all form +1 charges. Group 2 is +2. Group 13 is +3. And then for the nonmetals, we'll talk about as the -3, -2, -1. But for now, we're going to focus on these metals that only form one charge. You will also notice that zinc and silver are in there. Those are two other ones that we'll have to remember. Zinc is always a +2 and silver is always a +1. So these are the general rules for naming ionic compounds with single charge metals. So just as a quick reminder, remember that an ionic compound is a metal and a nonmetal. When you're naming compounds, that's the first thing you have to make sure you identify is what type of compound is it. So these rules apply for ionic compounds, and ionic compounds specifically that only form one charge. So remember from the last chapter again that metals become cations, so they lose electrons, and nonmetals become anions, or they gain electrons. So when you name an ionic compound that contains a single charge metal, the cation is named first and the anion is named second. When we name the cation or the metal, it's named using the element name. So for example, Na+ is called the sodium ion, so we would call that sodium. The anion is named by taking the root of the element and then dropping the ending and adding IDE. So for example, I- is called the iodide ion. So when sodium and iodine form a compound, it would be named sodium iodide. Another example you can see there, when calcium and oxygen form a compound, it would be called calcium oxide. Okay, so let's do a couple example problems here. So the cation is named first, which is going to be your metal. Anion is named second, which is your nonmetal. So basically what we're doing here is we're taking the name of the first element, dropping the ending, adding IDE on the second element. So for this first one would be sodium chloride, Ki, potassium iodide, Cas, calcium sulfide, CSBr, cesium, bromide, MgO, magnesium, oxide. Okay, so again, look at the pattern here. Name of the first element, you drop the ending on the second element, add IDE. And again, this only works for those elements that we talked about that can only form one possible charge. So we're talking about group 1, group 2, group 13, and then those couple transition metals that we talked about. So stop the video for a second. Go ahead and try these. Once you've tried them, come back and we'll go through them. Okay, so my first one, cesium fluoride. Next one, AlCl3, aluminum chloride, MgI2, magnesium iodide. And notice those little subscripts don't have any effect on the name of these particular elements. So it doesn't matter if they're subscripts, it's still just the name of the first element, IDE on the second. Rb2O, rubidium oxide. Last one, K2S, potassium sulfide. Okay, the next thing we want to look at is writing formulas for ionic compounds with single charge metals. So we're still talking about the same groups of metals, so group 1, group 2, group 13, and then the couple transition metals that we had talked about. And this time we're going to start with the name and we're going to translate the name into the formula. So when we do this, we still have the cation first and the anion second. So to figure out the formulas, you have to first figure out the charge that the cation forms and the charge that the anion forms. So again, this is why we wrote those charges on those periodic tables that we have. Group 1 is +1, group 2 is +2, group 13 is +3. Then group 15 is -3, 16 is -2, 17 is -1. Okay, so that's where we get those numbers for the charges. Then we're going to crisscross the charges down to subscripts and drop the charges. So we'll drop the plus and the minus. So you can see in that example at the bottom, aluminum forms a +3 or a 3+ charge. Oxygen is a -2 or a 2- charge. You crisscross them down. So the 2 goes down to the aluminum, the 3 goes down to the oxygen, and then you get rid of that plus and minus. If the charge was a 1+ or a 1-, then the 1 is not written. So if you remember from that previous set of notes we took, there's an implied 1 if the element is there and there's no number next to it. And then if the subscripts are the same, they cancel out. And we'll do some examples with those. All right, so let's look at how this works. Okay, so group 1 was +1, 2 is +2, 13 is +3, 15 is -3, 16 -2, 17 -1. All right, so lithium is in group 1, so it forms a +1 charge or a 1- charge. Bromine is a halogen, so it's a -1 charge. So Li +1, Br -1. And then I'm going to crisscross the charges so the 1s come down. So Li1, Br1. Like we said, if they're 1s, you're not going to write them. And if they're the same, they're going to cancel out. So this becomes LiBr. Okay, next one. Calcium chloride. So calcium is right here, chlorine's over here. So calcium's a +2, chlorine's a -1. So Ca is a +2, Cl is a -1. Crisscross charges. So this becomes CaCl2. All right, next one. Aluminum oxide. So aluminum's over here with a +3. Oxygen is a -2. So +3, -2. Use the symbols. +3, oxygen -2. Crisscross charges down. Al2O3. So basically they're switching numbers and then you're dropping the plus or minus. So Al2O3. Okay, same thing here. Pause the video for a second and then come back and check your work. All right, so potassium nitrite. K is a +1. Nitrogen is a -3. Cross them down. K3N. Calcium oxide. Calcium's a 2. Oxygen's a -2. So calcium +2. Oxygen -2. Or 2- if you want to reverse and say it the other way. So this becomes Ca2O2, and here's an example of when we're going to reduce those. So this becomes CaO. Okay, the last one, beryllium iodide. Be is a +2. Iodine is a halogen, -1. Crisscross, BeI2. Okay, so the metal always gets written first, non-metal second, so cation, then the anion. You look up the charges based on their position on the periodic table, crisscross the charges. If it's a 1, you don't need to write it. If you can reduce it, then you reduce it.